Dear colleagues and partners, good morning, good afternoon, good evening, because I know we have people joining us from several time zones. Bonjour, grüezi. On behalf of the Data Science Competence Center at the Swiss Federal Statistical Office, I have the great pleasure to welcome you to this inaugural talk of the Data Science for Public Good seminar series. We have the honor to welcome Professor Slava Jankin from the Hertie School of Governance in Berlin for his talk entitled Data Science and AI in the Government. Professor Jankin is a professor of data science and public policy at the Hertie School of Governance in Berlin. Professor Jankin, you have a background in economics and public policy, but before joining the Hertie School, where you're the founding director of the Data Science Lab, you were in the UK and you were at the University of Essex. And I think of interest to our audience is that you served as Chief Scientific Advisor to the Essex County Council, and focusing on artificial intelligence and data science in public service in advising them. I am very, very happy to have you here today. Thank you very much for accepting the invitation. Professor Jankin, the floor is yours.
Thank you. I'm glad to be here. So let me share the screen and we can start. So let me start just following up on the bio and the introduction. This title slide actually is quite meaningful. This is Brandenburg Gate, if anyone recognizes Brandenburg Gate in the background, but we applied some pretty straightforward deep learning algorithms to recolor it in straight lines, but also using the colors of Hertie, the Hertie School. And this is our way of saying that we bring the heart of bringing digital and data science and artificial intelligence to the heart of government. And this is our aim. This is the aim of the Data Science Lab, but it's also the aim of the Hertie School of Governance to develop solutions for public good, for common good. And within the Data Science Lab, we're focusing on the data science solutions for common good, data science, AI applications in government and public policy. So that's where we are. But the talk today is about data science and AI and government. And I will describe a couple of things, but let me just immediately start to where we finish. We will briefly touch upon what we find in our work, our recommendations. So the aim of bringing AI and data science to government, the aim of this approach and the aim of this stream of work is to make government, to make public services more efficient, to make them more responsive, to make them more predictive, and also fair. So efficient, it's about generating efficiency within government in the delivery of public services. Responsive, focusing on the individual level and being more responsive to the individual needs that happen. And predictive is trying to go upstream and trying to solve the problems before they become big problems. So developing this foresight capability in government and enabling this foresight capability in government, trying to preempt rather than react as much as possible. Because often in government, it is much cheaper to preempt rather than react to some problems that appear. And also fair. And the whole discussion about AI and data science in government hinges upon the rollout of algorithms and algorithmic solutions to be as fair and transparent as possible. So all of this together is really underpinning the aim of bringing AI and data science in government. But what we find in our work is that a major constraint to bringing this is lack of in-house capacity in data science and AI in government. And this is from lack of sufficient expertise, or lack of really data science and AI expertise in government, in the analytical capabilities of government, but also it's really just lack of infrastructure, sufficient infrastructure, legacy IT systems. So a lot of things that we know from previous work on digitalization of government. A lot of these things come through as well when we try to bring data science and AI, but they are also becoming a bit more significant when we talk about dedicated and specific IT infrastructure that enables data science work or AI work in government. So for example, from not only legacy systems of IT, we're talking about bringing in specific computational capabilities. So using GPUs if you want to deploy deep learning models, for example. And this is an unknown concept in a lot of government departments that are built on legacy systems. So it's a small thing, but fundamentally the core thing that we found is that it's about human capital and developing this capacity and building it in-house. So what we recommend as a recommendation in our work is that recruitment practices need to be adapted, and they need to be adapted to keep in mind that a lot of the skills and talent that is working in data science and AI, they are working in slightly different domains, and they're working in environments that are not exactly the same as are used to in government, in public sector. So recruitment practices need to be adapted, and job attractivity for experts in these fields needs to be increased. It's anything from salary, but also for the flexibility of movement between jobs and in and out of government repeatedly. This is one thing that, as an example, we know that in government, quite a lot of the jobs, there would be long-term prospects of the job and slow progression in the job. But staying in the job for 20, 30 years may not be of interest to data science or AI professionals. They may be interested in shorter stints in government and returning to industry later, or seeking some other interesting jobs outside, for example, in international development. So HR processes and the general approach to recruitment and attractivity of jobs needs to be improved. There need to be communities of practice and centers of excellence being built, communities of practice allowing what can often be siloed units across different parts of government to talk to each other, exchange experience, and develop common best practices. And the centers of excellence that are working at the boundaries of state of the art in data science and AI, and continuously push it further, and also allow this state of the art to be propagating into the wider government community, wider data science and AI applications in government. We also propose collaboration with external experts and research institutions as a halfway house between the usual build or buy dilemma that is facing the government. So rather than going completely out of the government and outsourcing the development, as a halfway measure can be working with, for example, universities and NGOs in developing some of these applications, and through that transfer knowledge to build up capacity in government. Strengthening interdisciplinary and intersectoral networks as a more informal opportunity for people working in this field to talk to each other, but also not only within government, but outside, an exchange of knowledge and exchange of opinions that will be open to, for example, NGOs and universities and professionals in those areas, but also industry to exchange and transfer knowledge. And then one thing that seems to help quite a lot in order to simply raise the profile of data science work in government is to hold competitions, data science, AI competitions and hackathons that allow raising the profile, but also raising the awareness of some of the problems that are facing government, and bring this to the attention of young graduates working in the field, young professionals, but also more established experts who are interested in contributing to the public good. And finally, in a lot of efforts, it does make sense to centralize the resources, centralize the capacity in data science, but that shouldn't come at the cost of a lot of expertise that is being built in decentralized fashion. So it's a two-tier setup where you should have some central capacity, central expertise that can be deployed as needed, but also that shouldn't be detrimental to the development of more grassroots data science and AI capabilities that are picking up in different units and different departments. So these are the findings, and we'll return to that. And what I will do now is discuss how we got to these findings and how did we find these recommendations. So let me start off with a really brief definition. This is where we are coming from, how we approach it, because there are many definitions of artificial intelligence that will be floating around. Given that we are working in Germany, what we've done is essentially settled on a definition that is coming through in the European Union. This is the regulation of the European Parliament and the Council, laying down harmonized rules on artificial intelligence. So this is the AI Act that is currently going through European Parliament. And we're just adopting the definition from the AI Act. So in Article 3, there's the definition where AI system is defined as software that is developed with one or more of the techniques and approaches listed in Annex 1, and can, for a given set of human-defined objectives, generate outputs such as content, predictions, recommendations, or decisions influencing the environments they interact with. And what is interesting in this definition is that it's really just setting the tone, it's setting the framework, but it's also open-ended in the specific list of technologies. So this is referred to Annex 1. And specific list of technologies is open-ended because this is one of the things that we see in data science and AI is that new techniques appear all the time, and the speed of development is amazing. Some things that are developed 3, 4, 5 years ago, they're considered ancient history in a lot of the cutting-edge research that is being done, for better or worse. So within the Annex 1, this is the reference to specific list of technology that is listing machine learning, supervised and supervised reinforcement learning, including deep learning, but then also knowledge-based systems, logic systems, expert systems, and also statistical approaches. So altogether, this is essentially the current list of technologies underpinning AI. So with this in mind, what we want to look at is how AI and data science enable better governance. And with data science, we're essentially bringing this definition of AI that we just discussed, we're just bringing it closer to the real world data and how these technologies interact with data, so huge data resources that are available to government, and how it interacts with the wider context. So the legislation, regulation that is governing the deployment of that. So let me just motivate the discussion by referencing a report that was relatively recently published. So it's by now 2 years old, but it's a report by the Administrative Conference of the United States, which is an independent agency set up by Congress that is supposed to improve public administration and delivery of public services in the United States. And the Administrative Conference of the United States commissioned Stanford University and New York University to write a report about the deployment of AI in federal administrative agencies. Why I'm bringing this report is that because we really, when we're working on deployment of AI government, we're lacking a good overview about the existing use cases around the world. We know a little in every individual country. We have some success stories, some use cases that pop up in the media or in some reports that governments produce, but we lack a comprehensive overview about where things are with the deployment of AI in government. And quite often when we look at this patchwork of individual reports popping up here and there, we often face with potentially with an idea that AI is really not there yet. We have some trials in different governments. They are not really connected, and it's just one-offs that happen. What this report enabled is a snapshot of all federal level agencies, and it did a survey and a lot of investigative work based on public hearings in the US Congress, where you would get an idea about the deployment of AI across all levels of, as a snapshot across all agencies on one level of federal government, right? So it's a comprehensive picture, something that we lack for other countries. So it may not travel well to other countries because US experience may be specific. Every country will consider itself to be really unique and special, but it still gives us a lot of information about the deployment. So with this report, just to give you an idea of what we find, this report shows that actually AI is not something, AI and data science projects in government is not something for the future. It's already here. It's already deployed sufficiently widely across government, different stages of deployment. Some of them are quite mature, some of them are at the level of planning, but some of them are in the prep stages. But there's sufficient number of use cases that allow us to get an idea that things are happening across different agencies in government in the delivery of public services. So this is the table. It just shows different agencies. And you can see across the policy area, this is probably an illustrative case that the graph on the right-hand side with a number of cases. So you have, and the policy areas on the x-axis, you have a lot of use cases happening in law enforcement agencies, followed by health, financial regulation, social welfare, commerce, and at the end, you have housing and education. So this really picks up one trend that we also see in UK, in Germany, that a lot of the deployment of AI and data science in government is really being underpinned by availability of data and also cultural acceptability of deploying data science to answer specific questions. So law enforcement agencies have historically been using data as part of their decision-making process, and deployment for tactical decision-making and operational decision-making. Health, the same, it's a wealth of data, and data is being used in health decision-making historically. So it's not surprising that these agencies in these policy areas, they are at the forefront with the use cases and the deployment of AI. And it's also not surprising that, for example, education is really far behind in the deployment of use cases. So it's a generally sensitive area, but it's also not the area where a lot of predictive models have been previously deployed. But bottom line from a lot of this is that it's across a lot of areas of federal government in the US, but also the number of use cases, we're not talking about single digits. For a lot of agencies, we're talking about double digits as the number of use cases. So there's lots of experience. There's lots of existing success stories that are already deployed, fully deployed, and that are influencing, they're part of the decision-making pipeline. And in terms of the governance tasks, these are the standard, this is the bottom left, figure 2 from the report. These are the standard tasks of government. There's like areas of public administration that are commonly referred to, legal definitions of public administration covering regulation, analysis, monitoring, enforcement, public services, internal management, and adjudication. And it's also not surprising that a lot of data science and AI is deployed in monitoring and regulatory research and analysis, because that's really underpinning the function of this task in public administration, in enforcement. But it's also not surprising that much less is deployed to internal management and adjudication, because we're getting to the sensitive areas where using data for decision making. Right, so what we're describing now is the complexity of deployment and some of the things that we have to keep in mind for deployment of AI and data science in government. So this is just a couple examples across these different areas of government. From enforcement, it's from the Security and Exchange Commission, looking at fraud detection, the same with the Customs Office, food safety inspections. Then it's the research that is done by the Consumer Financial Protection Bureau, looking at the complaints that are coming from the customers, from the consumers. Food and Drug Administration doing large-scale data analysis of adverse drug events. And internal management, where the thing where we see less deployment is still looking at some augmentation of human decision-making in procurement processes, in legal compliance, and also in security, so cybersecurity. So there are lots of areas where this is deployed. Now, one thing that I wanted to focus on now, and this is one of the motivations for our work. If you look at the graph at the top right, this is figure 4, AI use cases by developer type. So this report also focused where these AI applications, AI data science applications have been developed. And you can see that non-commercial collaborations, this is NGOs and universities, they are a minority class. There's lots of commercial contractor development, so outsourcing the development. But majority of use cases are actually developed in-house. And the numbers are pretty drastic, almost twice as many use cases that are in the US federal government are developed in-house. And that's really what motivated our work. Why do we see this in-house development? And that relates to, because you mentioned my previous work in UK, observing how this deployment is being done in the UK. It actually links up quite nicely to what we observe in US. That there's certain reasons why we would want to see the applications being developed in-house, in government, rather than going outside and outsourcing them completely. Okay, so why should we focus on this in-house capacity development around AI and data science? And there are several reasons for that. And all of these reasons, we identified 5 main reasons why this may be the case. One of the key things that always comes up with working with government and deploying data science and AI solutions in government, this is one thing that I referred to previously, is around data. But data within government will be from a slightly different domain than data used in private sector, in industry. And this comes from the fundamental difference that the customers in private sector, in industry, the customers, when they share the data, it is often done on a voluntary basis. Most of the time, it's on a voluntary basis, or you sign the terms and conditions that you're giving up the data voluntarily as part of the service that you receive. But this is really not the case in government. Most of the times, data is collected without this voluntary agreement of the citizens, and this data is collected as part of the delivery of government services. But it also comes with a sensitivity stamp that is labeled on top of it. A lot of data in government is highly sensitive. And we can talk about social security data, we can talk about educational data, we can talk about data from the child welfare to adult welfare to vulnerable populations. A lot of these domains of government and public service delivery, the data that is being used there is highly sensitive. And it can be sensitive legally, so that legally it should be protected because it has protected characteristics that are cannot be de-identified. But it also sometimes sensitive in a way that is just a perception of this data leaking into the public domain is a high risk scenario. So you're working with civil servants that may be hesitant to deploy the data or allow access to the data for legal reasons, but also for the reasons of perception and risk assessment, perceived risk assessment of this data. So working in-house allows the development that preserves and guarantees this privacy and security. Things can happen in government just like anywhere else, but at least you're working within the existing rules and procedures in the government agencies, where the privacy of the data, security of the data is paramount. Similarly, the focus on ensuring compliance and accountability. Changing regulatory environments. Quite often this happens on short notice. You have changes in regulatory environment, and compliance with regulatory environment can have implications on algorithms. As an example, we think about the deployment of predictive models that influence individuals under GDPR. There should be a process for individuals that are adversely affected by algorithms to have recourse and explanation how they've been affected. That did not exist before introduction of GDPR. So an introduction of the new regulatory environment essentially led to redevelopment of a lot of systems that were designed before, because you had to build in this explainability and transparency component into the systems. Quite often it means that you move away from really complex but complex systems that are difficult to explain to easier and more transparent systems that maybe not as robust, not as accurate, not as precise, but they allow the degree of transparency and explainability. Another aspect that we found is that incorporating domain, political, and organizational expertise is crucial. So when we move from data to insights to decision-making, this three-step process, quite often the easiest part is moving from data to insights. But the jump, at least in government, what we observed, that the move from insights to decision-making, it's a complicated process that brings together political context and organizational context in each organization, which means that you need to navigate the political and bureaucratic hierarchy of the organization, make sure that results of the analysis are presented in a way that is useful and that aligns with the priorities of the organization, but also it aligns with the internal politics of the organization. And it's really difficult. This is often not codified, and it's really difficult to give explicit instructions to external developers how the model should fit internal organizational structure and internal organizational politics. One of the other things that often comes up is that the way that machine learning systems are designed and developed, they should be quite agile. They should be iterative. Things change quite frequently, even with the input of the data that comes in. We can think about models that were designed to work with customers pre-pandemic, pre-COVID-19 pandemic, where emails and messages from citizens to government were focusing on certain aspects, and the models that will be generated to work with this input of information, trying, for example, to filter it, to sort it, they would be trained to deal with this type of data. But with the pandemic, the type of questions, the type of issues that citizens are raising is completely different. So there's this qualitative jump in the type of data that comes in, but also the things that people discuss. So the models need to be retrained and the models need to be updated with the new data that comes in. And this is a dramatic example, but it also happens with any type of model. There's a general decay in accuracy and the performance of machine learning models. And this happens because of the underlying data generating processes change over time. So you need to update the models, you need to retrain the models. If any organizational changes are happening, you need to update even the full pipeline of machine learning models, how it fits with the business pipeline of the organization. And finally, developing capacity internally, even if it's at the minimal level. Not every organization will be able to develop the full life cycle of a machine learning model that is tackling a specific problem. But even if you have some minimal capacity, that will enable government organizations to be more informed customers of these processes. The procurement process can be happening with more informed, and officials involved in the procurement questions will be able to deal with external suppliers much better, just understanding what is possible, what is the realm of the possible, what systems can deliver, and what is being just promised by the vendors and cannot be delivered given the complexity of the data or the quality, even the quality of the data that is held by governments. So these are the core areas for success that we identified. These are the factors for the deployment of AI and data science projects in government. So how do we approach the building of in-house capacity in data science? How do we propose to approach it? So we identify capacity around AI, capacity around data science, and also capacity around solution development. So capacity around AI, this is really focusing on what we discussed about the definition of AI. So it's about machine learning, deep learning, about computer vision and natural language processing, depending on the specific use cases that government departments will face. So this is the technical statistical machine learning expertise that is being developed. The data science brings in the connection to the data, databases, distributed computing, and that's another level of capacity and expertise to understand how this will work. So it's anything from the really simply thinking about the quality of the data that the government departments hold, understanding the quality of the data, the types of data that are being held, and linking it up to what the models will allow you to deliver, and understanding if the two things can actually match and deliver something. But this delivery of something needs to lead to some solutions. And that's where we bring this solution development component as well. If we are talking about the delivery of data science and AI projects in government, one of the crucial things that we identify is that there needs to be understanding of the causal inference, causal analysis, so attributional analysis. When we talk about explainability, causality becomes crucial in explainability side of things, but it's also important in the delivery of process, or delivery of project, delivery of services in government, where they crucially hinge on this building a causal story, causal model of how certain things and interventions result in some outcome. Decision theory, how do you move from data to insights, but then also to decision making in the end, and how this decision making is really dependent on the inputs that are coming from the systems. ML ops, this is development and operations, so it's embedding machine learning systems. Because just development, so research and development component is not enough. You want to deploy the system, you want to monitor the system, you want to update the system when you see sufficient decay in the performance, and you want that this system is integrated into the decision-making pipeline. And it's also the governance component, so the ethics and the legal context around the deployment of algorithmic decision-making, of algorithms for decision-making, data science and AI products. It's the ethical side, what we talked about, the fairness, when I mentioned first, fairness. It's about the legal side, so anything from GDPR to data protection legislation to cybersecurity legislation. But also how things need to change. How do you relate the results of these projects of the analysis to delivery of public services? That's where the human-centered design and agile methods come in. And then finally is the governance and the policy making, so the politics of making decisions, but also the underlying structures of the governance. So that these three big blocks, they can be broken up into two technical blocks, focusing on the statistical machine learning component and the data component. And then the third block is essentially how to make all of this happen and not be relegated to simply the technical research and development, but actually embedding this in real government. And as I mentioned in at the start, in order to achieve that, we identified that there needs to be certain things that need to change. So it's anything from recruitment to expertise to cooperation, networking, developing these contests and growth. So recruitment, as we discussed, it's HR practices need to change and adapt to the new world. It's anything from the fact that data science and AI professionals are quite expensive. They can get a lot of money on the open market. So it's difficult to stick them into the civil service pay ranks. And sometimes they need additional allowances. Sometimes they need additional flexibility and freedoms in order to attract them to government work. Expertise, it's about the establishing a good community of practice and centers of excellence that we discussed. Cooperation with external experts and research institutions as a halfway house between private sector and government. Developing this contest, hackathons, competitions that allow to raise the profile, but also raise awareness that government does have a lot of interesting data, but also a lot of interesting challenges and problems. And quite often, professionals working in AI and data science are motivated by these challenges and problems, and they would be keen to explore that. And then finally, it's growth. that centralization that we see happening across different countries, centralization of this capacity in data science and AI shouldn't come to the detriment of really decentralized efforts and innovations that are happening across different government departments. One thing that we found an interesting statistic is that only 1 in 14 data science professionals in UK government is based in centrally. Everybody else is based in individual innovation units, data science units across different departments of UK government. So just to recap, the aim of AI and data science in public sector is to make it more efficient, to make it more responsive, to make it more predictive, and to make it fairer. And the major constraint that we found is lack of in-house data science and AI capacity. And the recommendations that we just discussed: recruitment, communities, collaboration with external expertise, networks, competitions, and centralization that should happen in parallel with strengthening of the grassroots efforts. And I think this is it. So let me just finish that. We wrote it up as a policy brief. The policy brief was designed to be available for German government during the coalition negotiation period. You can access the policy brief at the link on the slide, or just Googling the title and Hertie School, it pops up. There's much more details with examples for individual applications, individual sections, has plenty of examples and use cases to highlight how things are done across different countries, not only Germany, but around the world. And with that, I will finish. Thank you very much. Happy to answer any questions.
Thank you very, very much, Professor Jankin. Indeed, your policy brief was of great interest to us. I think it all started there. And I would recommend its reading to anyone because you really deep dive into suggestions and possibilities. But yes, I do have a few questions. One of them, and you just you did mention it, but it is not easy for governments to recruit, let's say, high-tech profiles, data scientists and AI, but also, other profiles, and maybe difficult to retain them. Do you have a few more suggestions? How could that be done? How have you got ideas about measures that can be taken by governments or HR departments to help recruit, keep people, keep them interested? Because of course we can usually not offer what the private sector can offer, but other things.
Yeah, exactly. So there are incentives that come in that government can offer that private sector cannot offer quite often. It's a question whether these incentives are sufficient, right? But one thing that seems to be popping up more and more around the world is just, if we think about how to attract these professionals, is just blurring or softening the rigidity of government HR recruitment process. It is rigid as it is, right? It's rigid for a reason. There are all kinds of procedures, but allowing some flexibility, for example, for lateral moves, not for the standard bottom-up progression that happens over time or decades, but maybe more lateral moves from industry into government, secondment processes. So allowing government officials to be seconded to private sector for a couple of years and then coming back. The same happening with universities, government officials being seconded, universities seconding expertise to government for a couple of years and then reverting back. Allowing that, this is all building this flexibility and allowing for unusual path of travel that many in career path that many experts will have. It's also possible that you have a lot of AI and data science professionals that don't follow standard educational process. You can have AI and data science professionals that many of them may not have completed a computer science degree in the university, but standard HR guidelines would be to hire only someone who has a computer science degree, which may not fit with a lot of people. Some of them may not even have a university degree, but maybe they have years and years of real world experience. So this rigidity works if you are competitive, right? So you can be quite rigid. Yeah, we're going to hire only computer science graduates. It's fine if you can offer competitive salary, or you can offer something else that is on par with what industry can offer, because essentially government will be competing with Google, Facebook, any other company that wants to hire computer science graduates. And it will be difficult competition. But if government is more flexible and allows for this more untraditional, unorthodox entry pathways, that even temporary, because some people are not interested to be stuck in the same job for 20 years, especially in the AI data science world, then that would make it more open. But also, this is one aspect about the HR process. But another aspect is that quite often what we face, and this is also in our interviews with people working in the field in computer science and AI in industry, they are sometimes not aware that governments are interested in deploying these tools. They are not aware that these problems exist, that there's lots of data that could be utilized, that, for example, governments are sitting on mountains and mountains of text-based data, so which is ripe for deployment of natural language processing techniques. And they just may not be aware or aware that this is of interest enough. And sometimes they will be just keen to be involved in order to contribute to the common good. So it's also being proactive and developing these competitions, as we call them. So it can be from hackathons to some more specific challenge labs and competitions that can be done. So these are like the two key areas in terms of recruitment, but also being more proactive and trying to approach people and being open to collaborations that are more unorthodox to government.
So you're saying you mentioned in your policy brief as well, you talked about it today. We are on the right track when we participate in a hackathon with the Swiss government. I know that the Swedes do Hack for Sweden. You did mention in your brief that Germany had something similar, yeah. Reboot Germany or something. Do you have, apart from hackathons, do you have any other initiatives in the same kind of initiative that you know of and that have had some sort of effect, that if effects that are difficult to measure because they might have an effect in 10 years when those young people change their mind?
So an initiative that is similar to hackathon but slightly more, I guess, protracted in time is the so-called challenge labs. US does this a lot, and UK does this a lot, where there's certain problems that are being put forward, and it's almost like an open competition. So less of a hackathon where the data is presented and there's some development that is happening on the spot. These are sometimes longer term, sometimes shorter term. They can be also quite quick with a quick turnaround time. But where you have a more complex problem that is being presented, and the teams are being designed to work for a prize, and the prize can be a monetary prize or some kind of other prize that can be designed. Teams are working on solutions. So we had a similar thing done at Essex when I was at the Essex County Council Chief Scientific Advisor. So we did a similar challenge lab where identifying problems that face different departments in government, regional government, identify what are these problems, how do you link these problems, would be all related to the business case. So they need to be solved. They are priority, maybe not the top level priority because attention span can be quite different, but they are a priority for government. And the government is willing to invest resources in that. And even if these resources mean simply a government official coming in and explaining the problem to the teams and spending time with the teams to explain how things work, how specific process and procedures of the delivery of this public service, how it works. And then teams are usually of interdisciplinary experts. Doesn't need to be computer scientists or data scientists, but it would help to have interdisciplinary teams where you have sociologists or public administration professional, and then data scientists, computer scientists working together to develop solutions to these bigger problems. And the ones that we developed at Essex, they were about half a year long. In the US, this is much more established. They've been running them for several years now. They can range from weeks to months to a year. And they are much, much bigger things compared to hackathons. So that's another example that I have off the top of my head.
Thank you. You mentioned resources, whether time or money, because it's at the end of the day, it will be about that. Centers of excellence, I'm not neutral here, but who pays? Because in the long run, it's about creating value for the whole of government. And I'm aware of that the answer is dependent on government structure and country structure. But do you have examples of how this can be set up and how the decision was made for who's paying?
So the cases that I've seen, so this is US government and also in UK, what I've seen is in US government, there's this infrastructure that is set up. There's at the top level that is essentially playing the role of facilitator and a matchmaker between the teams and different government departments. So it's the government departments that will be paying for that. Government departments themselves may be seeking, depending on their financial situation and availability of this innovation money, they can be seeking funding from other sources, for example, some innovation fund in central government. This is what actually happened in UK with the regional government. There was no money internally to dedicate to this purpose, but funding came from the innovation fund of the central government. And there was this matchmaking exercise of teams and government projects, and the teams were working on that, and the money was used. We're not talking about huge amounts of money. We're talking about really facilitating the work, sometimes with hiring research assistants. That would be some PhD students or undergraduates interested in the project, hiring them as research assistants to help facilitate this work, because quite often it comes on top of the regular work by the people who are on the team. So they are volunteering to do that. They're interested in that. They're interested for all kinds of reasons. In UK, that was academics volunteering their time because they're interested in delivery for public good. But they still needed support. So this money from Central Government Innovation Fund was coming in, and it was about hiring research assistants that would help with the work of the team. And in the US, that would be from different departments that are part of this competition.
Thank you. Which leads me to the next question. Do you have the best practice or a top 10 of countries, or have you identified a country or several countries that might be maybe on the right track or are ahead of others, or who have made some critical transitions in that respect?
You mentioned your bias, I made a bias here as well. So I think, obviously, I think that UK is on the right track and has done a lot of work in this area. Partly it's because they started earlier with the digitalization and digital transformation, and there was an effort to digitize that happened earlier, and a lot of the, as we mentioned, a lot of the deployment of AI and data science cannot happen unless you have data that is available, right? So once you build the data infrastructure, the digitalization process, it's the next step that is easier to develop. You shouldn't do it sequentially. I don't, some people think that it should be done sequentially, but this is a separate question. I don't think it should be done sequentially. So sometimes when you hear what you hear in Germany is that let us digitize first, and then down the line we'll move to AI and data science. Given that digitalization in Germany, we still used fax machines last year during the pandemic to transmit information about the cases. Given that digitalization is not a solved issue in some countries, waiting for the developments, waiting for this to be done first before you move into data science and AI, it doesn't help with the capacity building, because you can really start developing capacity while you have, even at the minimal level of digitalization, there's a lot of data that is already available. even the governments that are a bit further behind in digitalization, there's still lots of data. And you can start building expertise, best practices, communities of practice, centers of excellence that bring this in and develop this capacity already. So that's probably like a hint at the laggards in this case, but more about the countries that are at the forefront. I would say that a lot is being done in UK, and I'm like constantly amazed by how much effort goes into that and how open and transparent a lot of these efforts are. This also helps. This is also a selection bias effect because we know a lot about what is going on in UK. So it's easier for us to see UK as an example at the forefront. Maybe other countries are doing this as well, but less public about it, and then it's complicated, right? We don't have this visibility. But UK, I've seen examples from Singapore, and a lot of things have been done in US at the federal level. But this is one thing to keep in mind, that a lot of things are also happening at the subnational level, at the city level, at the regional government level. Those things will be less visible, but it also makes it a slightly more complicated picture. I don't know much about Switzerland, but you would expect that maybe at the cantonal level, there would be a lot of things happening at the city level, where you're much closer to the delivery of public service. Data is available. You could deliver, they may not look fancy and flashy, but there would be data science projects, AI projects for delivery of public service. So it's a complicated picture about who is at the front, who is at the who is lagging behind, and I think it varies across different levels of government as well.
Yeah, absolutely, and definitely like Switzerland. We are at the federal level, but a lot is happening at cantonal level and city level. So absolutely, because it's also grassroots and service-oriented solutions. I have a question for you about this balance act for government, because we have also to govern algorithms. Then we want to, like you said in your brief, govern by algorithms. And also, if we want to generate long-term value for the government and a deep value for the government, how, maybe we can't avoid it, but how do we avoid going only for the low-hanging fruit when we embark on this data science and AI journey? Because of course you can automate a lot of processes. There are a lot of legacy systems, and there's a big temptation and a need and a cry to do that first. But how do you prioritize? Because that's very useful, but in the long term, if we wanted to data science for public policy, we might need to embark on longer journeys, longer analysis, and sometimes resources are more difficult to get for these projects with a less immediate effect. Do you have any recommendation how to prioritize, how to organize that within government?
Yeah, so the easy recommendation is to say you need to do both, right? You need to do short-term low-hanging fruit, but also long-term development. But it's actually coming from the fact that in our work, what we found as well is that, and I mentioned this in the presentation, that a big problem is cultural change. It's internal governance procedures, organizational processes, but deployment of AI in government, a lot of times, and we have other papers, like a couple other articles where we focus really on that. What kind of cultural change is needed if you want to embed AI and data science in government? And cultural change quite often comes as the biggest stumbling block. So capacity is one issue that we discussed today, but another is just cultural change. You have a lot of hesitancy of using algorithms or using data science and AI. You have lots of hesitancy based on just familiarity or lack of familiarity with the topic, but also sometimes influenced by external information that comes in. So something in the media talking about algorithms being used for abuse, and there are obviously cases where this is happening. We have lots of examples where algorithmic decision making has been deployed and to detrimental effect for citizens. But a lot of times this is like a combination of being hesitant because of lack of knowledge, like lack of expertise in the field, and that's why the capacity building can help, but also hesitancy due to these external factors that may be influencing that. So one thing that often helps is to show that AI can be done within the governance framework of delivery of public services. It can be done safely and it can be done transparently. And those low-hanging fruits can help with that. It's developing quick wins, success stories that you can then take on a roadshow across government to highlight that these things can be done. And they can be like, we can do it already. It is already done. This is something that you can do. You can think about adapting this to your specific environment within your specific department and adapt it to your business needs. And this is where these small cases help, because you can deploy them quickly. You can be quite agile in developing really small fixes, quick solutions that may not be life-changing, but they can be increasing the efficiency of government. And this is something that people in government will understand. They will understand that increasing efficiency helps. And that can be a way to help to change culture. And that's a step, right? And in parallel, you can work on longer term, bigger issues. For that, you need the buy-in. You need the buy-in of stakeholders. And it's the hierarchy of organization. It's the top level management. It's the mid-level management that is often the stumbling block in that. It's the political leadership. You need the lineup of all of this in order to deliver long-term project, long-term solution. But it would help to line the stakeholder engagement if you can show some success stories. So that's back to my initial really quick and easy answer that you need to do both. That without short-term success stories, it will be difficult or almost impossible to deliver that is something that is longer term, more transformative.
Thank you. Well, I think that means we have some work for some years to come. And I also think a cultural change, that's something that comes up in different countries, and that's absolutely vital, and not even necessarily linked to that specific technology. I think time is almost up, unless you want to add something, but I would really like to thank you very much for your great presentation and this extremely interesting conversation. I would encourage people to read your policy brief. It's full of insights, and I also personally want to thank the team in the background that helped us pull this off. Thank you very much for accepting to be our inaugural speaker in this Data Science for Public Good seminar series. That's, let's say, it's another of these acts to bring something of a change of culture. We're trying, and we're looking forward to the conversation and the communities of practice and bottom-up exchanges that we hope we can start within the Swiss government. An immense
thank you very much for the invitation. Thank you.
Thank you for joining us. Thank you very much. Dear colleagues and partners and everyone, thank you for joining, and have a very nice day or evening. Thank you.
Bye.
Bye.